properly?
Yes.
Okay, good. So as mentioned the last time we had a lecture, today we're going to continue with the Python tutorial. So let's start where we left off. So let me bring up the slides. So last time I gave you a bit of an introduction on Python. Why are we going to learn? Why are we going to be learning Python? The impact of the language in the software community in general, and then some of its uses in robotics. And then I would just like to stress that there are a lot of resources online. So if there is something that you're missing, that you don't understand, you can always ask me, but also you can also go ask me or Professor Focky in any case. But there are also lots of resources online. So and it's everything very well documented. So again, you can always ask us, but there's also a lot of resources online. So let's continue then. So first of all, I'm going to show you the interpreter, the Python interpreter, which is basically a command line application that comes along with Python. So I'm going to show you first. What I would like to show you is, in case somebody had problems with the virtual machine, I'm going to start the process from zero. So now you can see my screen, right? So what you see here is this VirtualBox. Now I'm running it in Ubuntu 20. I tested the virtual machine that I just created on Ubuntu 20, Ubuntu 16, and Windows 10 on 2 different computers, as I mentioned in the announcement. So in case you haven't created the virtual machine, so what you need to do is click on New. Then here you give a name to the virtual machine. So for example, if you start typing Ubuntu, it will automatically switch to Ubuntu 64-bit. Then you do next. You assign the size of the memory. Usually I do around 8 megabytes, which is the recommended for the kind of applications that we're going to be doing. And then here you use an existing drive, and from here you select the .vdi file that is in the one that I uploaded. Some of you contacted me asking if you could use the one that that was already there, because you already got it working with PyCharm. So there's no problem if you do that. But now we're going to be working on this one. But if you find any trouble because of the different version of the virtual machine, or again, you can always email me, and we will try to sort it out. So let's start the one that I already have here. So let me change the screen that I'm sharing. Okay. Stop share. Okay, now what I'm gonna share is this one. Okay, so now this should already be working with the right size of to view the virtual machine. Sorry, because I don't see the menus. Okay, yes, here. So here you have the menus, and then if in case you still have the problem with the window size, you can click on auto resize. Sometimes I had to click twice. I don't know why it's that the problem, but in any case, so let's go back to the slide. So the first thing that we need to do is open a terminal. So we're using Terminator, which is already included in the virtual machine. And what where you can find it, you can just open it by clicking on the icon on on the taskbar on the left, which is this red icon with multiple windows, or you can open a terminal using Ctrl-Alt-T. And then on this terminal, we're going to type Python, and this will launch the interpreter, as you see in the image that I'm showing. So let's do that quickly. Okay. So let's click on this. Then we type Python with just one T, and then this starts the interpreter. As you see here, the default version is Python 2.7. So here you can do math operations like 2 + 2, or you can import, as you will see later, we can import already modules from Python to be using. So it's basically like the command line of MATLAB for those who are familiar with it. And this is like a tool that you can use also to do math operations, like quick tests on Python. So in order to exit, we can type exit with a parenthesis, and then this will lead us take us out. But also you can do Ctrl-D, and this can also take us out. If you just type exit, then it will tell you use exit or type Ctrl-D. Okay, so there's that. Then let's continue. So this is what I already told you about about exiting. If you want to learn more about Terminator, you can follow the link below. Now we can also run a Python file directly in the terminal. So in the same terminal that we opened, we're going to type this command, and then we are going to see this, which is one of the files that we're going to be using for our lab sessions. So let me show you this. Okay, so let's type Python, and then what we're going to type is ROS workspace, then source, then, so one thing that you can do is source, we say source because this is the source folder, which is usually called SRC. Then let's say you don't remember the name of the folder, you can type part of it, and then you can type tab, and it will autocomplete. Then if you don't know what's next, then we do robot control. Then we want to run a file that's called L1. I know that it starts with L1. Then it will, because it's a lab one, then we autocomplete, and then this will run the Python file. And then this is what we see. The robot just moving up and down. This is one of the examples that we will be using, and then the script closes the file on itself. Okay, so let's continue. So let's try our first program. So this is the first thing that we're going to be doing. So let's try it out. Okay, so what we're going to be doing is, so first, it's very important for our lab sessions that we run PyCharm from the terminal, because you can also run it writing PyCharm here, and then you can click here. But it's important to run it from the terminal because when you open a terminal, we run a number of commands, and one of those commands is loading the libraries that we need to run the examples that we're going to be doing during the lab session. So it's important to run PyCharm from the terminal. So we do here, and then it's going to take a while. Now here is going to open the last session that I had opened. So probably what you're seeing is this, which is basically the same file, the same example that I showed you. And for those who are using the new version of the virtual machine, if you press play, it will run the same thing as we did before. But let's try something else. So let's create a new project that we're gonna call Python project 1. I don't know, let's call it so you can give it any name. I'm gonna give it tutorial underscore because I already have a project called tutorial, where I was testing things. So an important thing is to choose the right interpreter. So as I mentioned, we're gonna be using Python 2.7. So we choose the Python 2.7 interpreter. This will create a virtual environment, which is basically an enclosed environment where you can install and do libraries without messing up with your own system. And let's keep for now this create main.py welcome script, just that we can just test it. So we're going to create this project. And I'm going to use a new window because I'm going to be using the one again. So this will open the new project in a new window. And then this is basically the basic file that it created for us. Now, if we click on play, this will run the thing. So this is just basically defining a function, which I will explain later on. And then it runs this. This is the function. The argument is a string. And then it prints hi plus the string that you put, basically, right? Which is what we're seeing here. Hi PyCharm. So this is the name of the file that we're running, tutorial underscore main.py. And then this is running hi PyCharm. So now let's try something different, right? Let's say we want to run one of the files in our example. So we click on this, something, there's something from Zoom. Then we click here on edit configurations. Then we want to run the same file that we run from the terminal, right? So here it appears where we are, which is the main.py. And then we go to this, we click on this ROS workspace. WS stands for workspace. We go to source, and then we go to we try to look for the file that we just ran, which is in the folder robot control, and then one fixed base joint space control, the first one that it's there, .py. And then this is going to load the file, and then we do OK. And what's happening is that the file that is here is the one that's going to be running. Okay, so if we press play here, we're going to see that there's an error. Okay, so what's happening is that PyCharm up to now, it's only using the libraries that are in the virtual environment that we just created. So we need to tell PyCharm where are the libraries that are in our system. Okay, so we go to File, Settings, then we go to the Project tab, which is here, then Project Structure, and here you can see the libraries where everything is. So the libraries that are included in our project. So we can click in Add Content Root, and this will open basically the file system in which we are. So what we want to do is we go to where everything in our local system is. It's in the user folder. So there's this USR. It's, if you know about the Linux file system, there are several folders. This is referred to user defined files. And then we go to lib, which stands for libraries. Then we look for now Python 2.7, which is here. And then we have to look for dist packages. Okay, so this is basically all of the packages installed for Python 2.7. So we add it, then we do OK. And then if we try to run the same file from here, we should not have errors. In case you have errors, it might be related to the fact that you're using an old version of the virtual machine. How you can fix them, let's wait until this finishes, is by, again, you go to File, Settings, because there are certain paths that are not included in the file. So what you need to do, in case you were not able to run it, you do here, and then we need to look for ROS specific libraries. So those are in OPT, which stands for optional. Then there are two that are important. One is here ROS, and then we go kinetic, live, and again, ROS kinetic. Kinetic is the version of ROS that we're going to be using. And then what we need to look is Python 2.7. And then again, these packages, we add this to our project. And then the other important thing is you might have problems with something called Pinocchio. If you have problems, then you go again, and then you do open robots, which is also an optional package, libraries, Python 2.7, and then here it says side packages because this is related to the name that was given by the developers of the software. So okay, so we have this sorted out. So this is in case this is going to be useful for the future labs. So let's go back to our previous example. So now what we're going to do is that we're going to create a new file. So file, new, and then we're going to say it's a Python file. Let's give it, I already have a file called tutorial.py. So let's try to do tutorial_.py. And then we do a Python file. Okay, so this is our file. So let's try the file that it's on the slide. So first of all, we define x equal 4/3, which is a division. Then we do y equal a string called hello. Then first, something that is important is to add comments. So here, for example, to add a comment, you use a hash, and then just a comment. Then we can do another comment here. Now, as you can see, these squiggly lines below, because we're using an IDE, it tells you like proper PyCharm is configured to tell you also like proper guidelines to do coding in case you want to be standardized. And then now it's telling us that we need a space between this hash and the comment. So we do that. And then we continue adding this division. And then we use an if statement, 3.45/2, or y equal, and then you can see that here I'm using double quotation marks. You can use single or double quotation marks to specify string. An if statement, it basically checks the conditions that you're showing. So it's very clear that if you say if this is true or this other thing is true, then do what's below. Now, what's important to say, and I'm going to also stress it in next slides, is that indentation in Python is very important. So as you can see, if you press enter here, it puts me right on the correct position to continue coding inside of the if statement. So here, let's see, print, and then this is for Python 2. You don't need to put parentheses. For Python 3, when you do the print is it's a method, and it requires parentheses. Here is not the case. So we can do before the addition is something. I'm just copying the file that I the code that I showed you. X equal x plus 1, then y equals y plus. So you can also add strings. Now, if you have multiple quotation marks inside of the string that you want to put, you can use, so in case you want to put double quotation marks, you use triple quotation marks, for example. So in our case, we have tutorial. Oh, I skipped a line. So let's do this. Well, y plus world, and here let's put a comment that says concatenation of strings, and then here we have a tutorial, and then let's put double quotation marks just to show you, and then we go back and then we do print X, print Y. Okay. So here we still have the previous file. So what we want to do is change the file that we're running. So we are having tutorial underscore. So one way to do it is basically click here, do edit configurations, then select the right file. So we need to find our project, which is here. And we have our file, which was created somewhere. Oh, I didn't create it here. Sorry, guys. It created. Okay, let's copy this. We create a file here, new. Okay, now it shows the menu there. So let's again try tutorial underscore Python file, and now the file appears here. Now we copy what we did. Again, we come back here, edit configurations, then we go to our folder. Now we look for our PyCharm project, and this is here. This is our file. Okay. So okay, and now it changed here. A faster way to do it is just doing Control Shift F10. This shows here. So if you do Control Shift F10, it runs the current file and it changes automatically there. So here is what we just did. Let's go back to the slides. Okay. As I mentioned, an additional note is that from Python 3 and onwards, you need to add the parentheses to the print command. So this example, it's useful to see basic data types. So remember that Python is dynamically typed, so you don't need to specify the type of a variable before you use it. So for example, in C++, you first need to put if it's an integer, if it's a double, etc., etc. So here, an integer. So the default type of numbers in Python, it's integer. So if you do this division, the output of this is going to be 1 because it's an integer division. Then we also have floats. So for example, if the value has a decimal, Python understands that the value that you're defining, it's a float. These two can be of 32 or 64 bits. For example, if you're doing an application that requires to be fast or compact, you can specify the number of bits that you want to use for both integers and floats. Then we have strings, which are defined in Python as sequences. So are of the type sequence, which we will see later. But this is important, for example, for loops. As I mentioned before, white space is significant in Python, especially indentation. It's important because if you have indentation errors, your code won't run. And if you want to specify a new line, so for example, for readability, at the end of the line, you add a backslash, and then when you end the line prematurely, and this line will continue on the next one. And we don't have braces, so we never add braces. So in C++, for example, in between a for cycle, you have two braces. Here, we only use indentation. And for example, an IDE like PyCharm, as we're using, will tell you if you have indentation errors. So that's also an advantage of using an IDE. Those squiggly lines that you see below the lines of code. Okay, so back where we were. So an IDE like PyCharm will tell you if you have indentation errors. So that's also an advantage of using IDEs. Now, here we have the example. So for example, this is our if statement, right? Which tells you if this condition or this condition is true, then run what's below. And then you always need to add this indentation here, okay? Now, it's important just to mention that comments, whenever you're writing code, they are key for others to understand your code. So if you want to share your code with somebody, also for yourself, because sometimes you write an instruction, you do something like a strange operation, and then you don't remember why you did it. It's good always to add comments as we did. So to add a comment, we use the hash character. So here I mentioned, of course, in this case, it's just an example, but usually comments need to be meaningful, so not just a comment. Then it is also good practice to add a documentation string at the beginning of the Python file, something like this. So this documentation string is usually defined by 3 double quotation marks, and in between you put like a quick explanation, and then when was it created and the author. Okay. So now let's go to something that is key in Python, which is sequence types. So sequence types are a type of variable in Python that allows you to store multiple values in an organized and efficient fashion. So this can be mutable or immutable. This is very important, and we will talk about it later in other slides. So mutable types allow to modify in place an object. Now we'll see that in object-oriented programming, everything is an object. So when I talk about an object, I'm basically talking about an instance that you created inside of your program. And the elements of this object can be changed after you create them. On the other side, immutable objects, you cannot change it. And this is, I'm just telling you forward that this is one of the sources of mistakes most common that we see in Python. And there are different types of sequence types. So first, we already saw strings, which are immutable type. Most of the built-in types that you find in Python, they are immutable, unless they are specific types. There are also tuples, lists that are mutable, and then we also have dictionaries, which are special. We will talk about this some of this now, but we will gonna be mainly using what it's called NumPy arrays, because we're gonna be using NumPy because we're gonna be using a lot of its linear algebra functionalities that for our labs, but they work similarly to basic sequence types. And if you want a detailed explanation on sequences, you can go to the documentation. So lists, let's start with those. And I'm starting with lists because they are the easiest to understand, and also because the others are kind of they're subgroup of lists. So lists are just, the name is very self-explanatory. So it's a list of values organized in a specific order. So to create a list, we use square brackets. We will show you in an example. Lists can contain elements of different types. So you can put a float, a string, an integer inside of a list, and they are mutable. So you can change them after you created them. And they are zero indexed. So that means that the first element is 0. Unlike, for example, MATLAB, where the first element is 1, if you try to look for an element in MATLAB that is 0, it's going to throw an error because it needs to be a non-zero integer. And then we can create copies of a portion of a list using something that we call slicing. So now let's try this small example. Okay, give me 1 second. Okay. Okay, so let's see this small example. So now what we're going to be using is the built-in console of the of PyCharm. So here, to go to the built-in console, you click on the bottom. It says Python console. So let's try this. So this is the same console that you were running in the terminal that we opened a while ago. So let's create our random list. So let's start with a string, another string, and an integer. So this creates a random list. So if we type random list, it will print the values that we just defined. Then if we want to get a value from this random list, we can access it by putting in between square brackets the index of the value that we want to get. So this is, for example, random list 0, it's the string red. Then we can also change the value of the string by typing, by assigning it to a specific value. So let's say we want to put the number 55. So if we do this and we reprint our list, then the number 55 is going to appear there. Now, another way to access, a value is by, we can also use negative indices. So for example, if you use -1, it will start counting from the first element, which is the 0 element, backwards. So if you put -1, it prints 42. And then we can use what I just mentioned, which is a slicing. If you want to access a portion of the list, and you can access it by doing similar to what we do in MATLAB, but it's a bit different because it has much more features, but that makes it difficult to understand. So for example, if we do this, what it does is that it takes all the elements from the beginning to the last index, to the index that you're writing here, -1. So for example, the index here is 2. So as we remember, our list has 3 elements, 0, 1, 2. So it's not taking element 2, but 1 before, which is the 55, and then bacon. So then if we try the opposite, this will start from 0, and then this will return the entire list. So if you do it from the other side, it starts actually from the one that you're putting, and then it goes all the way to the end. Then you can also do a similar thing, random list, by specifying from the left and to the right where you want to go, and this also gives us from the 0 element to 1 before the index that you're putting on the right. Okay, so let's go back to our slides. Okay, so then we'll go to tuples. So tuples are similar to lists, but they are immutable. And to create a tuple, so instead of putting them in between brackets, you just separate the values with commas. You can also use parentheses, but you don't need to use them. But we cannot modify the elements of a tuple. So we can access the same way as we do using slicing, and we can access an element using square brackets, but you cannot modify them. So in the example that I'm showing below, I'm not going to do this in the terminal. Here we are defining a tuple. You see that their square brackets are gone, and then if we call the variable, then it prints it, but with the parentheses. So a good way to recognize if you're dealing with a tuple or a list is that if you're printing it and it's in between parentheses, it's tuple. Then to access an element of the tuple, you can use it the same way as with the lists, and then this calls the element. But if we try to modify an element of the tuple, it will throw an error because it's an immutable object. So it doesn't support assignment because you cannot modify it. And then we can do a slicing the same as we were doing with lists. Dictionaries are a bit more complex, but they can be very powerful if you use them properly and in the right situation. So a dictionary is mutable, but it's a list that it's not ordered, so it's not bounded to numbers. So basically, every element in the list, it's made of two parts: a key and a value. And if you call the key, it returns the value. So instead of calling the number, you call the key that defines the value that you're specifying in the dictionary. And you create them by using curly brackets. And here's an example of a dictionary. So here you see that we're creating an element whose key is guava. And then we say, we define it as a tropical fruit. Then we also define a second element, which is key is Python, and its value is a programming language. This is a string, but you can also define a key, which is a string called the answer, and then we can use an integer, which is 42. Oh, sorry. So if you call the key, it will print the value itself. And you can add new keys because it's a mutable object. You can add new elements to the dictionary by just defining it like this. So as we did for lists, we put here the index. Here you put the value of the key and then the new value here. And if you print again the definitions, then you get the extra element printed. Now there are functions. The functions that I'm going to show you now, they apply to all of the sequence types. So if they're mutable or immutable, so it doesn't matter which one is it. So to find the length of a sequence, you can use the function len. So if you do len and the inside parenthesis, the variable that you want to see, it shows you the length. So here it's a bit cut out, but it's 3 because that's the length of the list. Red, it has 3 elements. You can also check if an element it's inside inside the sequence that you're looking for. So for example, here I want to check if blue it's part of the tuple random of the random tuple. So it spits out true in case it belongs, and if I look for red, then it's going to spit out false. And this is very useful, for example, if you have a very large vector and you're just looking for one element of that vector, this function is very useful. Then if you want to concatenate two sequences, you use the plus operator. So for example, here we have hello, which is a string, which is a sequence, and then a space and world, and then we concatenate them using the plus. And then there's another operator that it's the star. What it basically does, it multiplies the inputs and, let's say, cast them the number of times that you're multiplying. Now we need to be careful because plus and star, they are different actions in NumPy because they are related to linear algebra. So this is sum of arrays, or like matrix sum or matrix multiplication. Well, actually star is not matrix multiplication, but it's coefficient wise multiplication. But we need to be careful that this for NumPy arrays, it's different. Then because lists are mutable, there are operations that are exclusive of lists. And I mentioned here that because they are similar, but because lists are mutable, they have operations that are exclusive to them. So some examples of these operations are append, which what it basically does, it's so for example, here we have defined a list that it's 1 to 3. And if we print it, it prints 1 to 3. But then if we want to modify this list and add a new element to it, We can do it by using append. And we're appending here A, and then the new, well, lists will add the element A to the list. Something important to note is that if you want to append, let's say, another list, it will take it as one element. So here we're appending 3, 4, 5 to the list that is already made up of 1, 2, 3. And what happens is that it creates a single element out of that. So if you type list index 3, what it will spit out is the whole 3, 4, 5. It's not going to spit out 3. And if you want to get a single element of this, you would need to do like this. So from the element 3, you take the element 1, and this is going to print 4. Okay. Then similarly, we have insert. And insert, what it does, instead of putting it to the very end, you can specify after which, in which position you want to put the element that you're inserting. So for example, here I'm inserting A inside of in index 1. Then you can also use index. This is also useful if you're looking for a particular element. So here we define the list 1A car, and we want to find the index of where car is. So you use the function index, you type the value that you want to find, and then it spits out the index. Similarly, you can use count. So if you want to see the number of times that an element repeats in the list, yeah, you can use count. So for example, we want to see the number of times that car repeats in this list. So we use count, then the value of the element, and then we use 2. And then it spits out 2. And there are lots of list-only operations. You can go to the documentation because this is only a 2-hour tutorial. There's not enough time to do it. Then reference semantics. This is one of the most important things that I'm going to talk to you about today, because this is related to mutability and immutability, and then this is a source of error that in many of the programs. I mean, I still make these mistakes because I don't declare properly the variables. So memory assignment in Python can be a bit counterintuitive. And if you don't understand how properly how memory is assigned in Python, you can have many errors. So let's start with an example. So here we are basically creating, as I mentioned, an immutable object. Most of the built-in types in Python are immutable. So for example, here integer is an immutable object. So we're assigning a equal 3. And then we're saying, okay, we have a b variable that is going to be equal to a. And then we modify a, which is 3 plus 1. And then I'm just printing them out. So the output of this, I think it's pretty evident that this is going to be 4 and 3 because we modified a and we assigned b, and then this is going to give us our 4 and 3 in the printouts of A and B. No problem. Now let's talk about another example. Now we're defining a list, which is a mutable object. And we're doing basically the same thing. We're assigning B equal to A. But now what we're going to do is that we're going to modify A, which is by appending it with a list exclusive operation. What we're adding the value of 4 to the end of the list, and the output of this, one would expect a similar result as before, but actually the output of this is this one. So the value of B was modified even if we didn't modify it ourselves. So what happened exactly? And this is related to what happens in the background when you create an object. So let's go a bit on through how does that work. So let's go step by step on what's happening in our first example, okay? So what happens here in our first line is that we first create an integer. Well, what the computer is doing is it's creating an integer tree and it's assigning a value in memory. Then it creates a name that we are defining, which is a, and then it assigns a reference in memory location of 3 to the value of a. Okay, so far so good, kind of simple. Then in the second step, what we're doing is we're creating a name b, and then we are putting it to the same reference as a, right? Then in our next step, what happens is that because a is immutable, it needs to create another entry in memory with a different value, which is, in this case, it's 3 plus 1, which is 4. And this is why b stays 3 and a is becomes 4. Okay, so this is the case for immutable types. Now let's go to mutable types. So we create our list, the same steps as before. You create the list, assign the value in memory, then you create the name, and then you create a reference in memory to the name a. So this is the same as before. Then for b, we create the name b, and then we assign it to the location in memory. Now, the interesting thing happens here, because a it's a mutable type. Instead of creating another entry in memory, what it actually does is that it's actually modifying the same entry in memory. So this is so it's adding the 4 to the entry in memory. So this means that the reference of b is pointing to the same place in memory that has been changed by the instruction in which we are now, which is append. So this is why in our second example, when the output of a and b, it's the same, because they are pointing to the same location in memory. So let's go a bit and give you an example of debugging using PyCharm. So I'm gonna share my screen now. This blocked, so I need to type this again. So let me go to my already made thing. Okay, so when we're running code, we usually want to understand why things happen, and it's really difficult if you only have one run. So what we do when we do debugging is that we want to run line by line and see how the variables are changing. So we can do this in PyCharm by adding breakpoints, which are these lines. So we add a breakpoint by just clicking next to the number of the line in which we want to put the breakpoint. So this puts a red dot here, and let's add 2 breakpoints, one at the very beginning of our first example and one at the end. So to do the debugging, in most of IDEs, it's represented by a box symbol. Here it's kind of a beetle. I think that in Spider it's actually a spider. But to do debugging, we just click on it, and what it will do, I'm not running the right file, so because I run the other one. So let's run tutorial example, and then if we run our thing, it stops in our breakpoint, and there are no variables defined. So what we can do is run step by step. So we can run this instruction. This means different things. So for example, if you do a step into, if there's a function, it will send you to the function definition itself. But we don't want to do this. There's also different ways. So for example, if you have created your own functions, these will actually just jump into the functions that you created, not on the built-in one. So this won't jump, for example, in print. So let's do one step. So for example, here we see that the value of a is 3, and then it also appears here. And then you can do a lot of things. You can also modify on the fly the value of a variable. So let's continue going line by line. B changes to 3. Then this stays because these are immutable objects. And then we continue. Now we get to our second breakpoint. If we do resume in the previous one, it will run the whole thing. Now let's go to our second example. Now A, it's going to be defined as 1, 2, 3, and this defines this list. And then we see the value of the list changing here. Then it jumps. If we go to the next line, we will see that B is changing. Then we are in this line append, and then if we run it, we'll see that both of the things, both of the variables are changing, and this will give us an insight on what's actually happening in the code. And this is very useful also in the case when you're trying to find out what's happening, because it might be that your code is running, but it's not doing the thing that you want. So you can actually see the values of the variables as you run it. So let's go back to our presentation. Okay. So as I mentioned, debugging is one of the main features of an IDE, and you can run code step by step. And we can, as I showed you at the very beginning, we can set it up to actually also debug our scripts for the lab sessions that we're doing, and that use ROS libraries. So usually, as I mentioned, I'm just putting here in the slide, so that you remember. Here you have the icon to do the debugging. Now let's go to logical expressions and operators. So when we talk about logical expression, we usually talk about Boolean algebra. And in Python, true and false are built-in unique constants, which basically means that are reserved words inside of Python. And you can have equivalent values for true and false. So for false, for example, 0, it's equivalent to false. The special word, the reserved word none, it's also false. If you define an empty container object by using square brackets, that also is equivalent to false. And true, it's all non-zero values, any number or non-empty objects. And we have different operators to compare by value. To compare if two elements are equal to each other, we use equal, so two equal signs, because if we use 1, that's an assignment. Is not equal to, it's defined by an exclamation mark and equal. We can also use less or greater than, or less or equal, or greater than. And here we see an example. We have two lists defined, A and B, and then we just want to see if they are equal to each other. And of course, they are equal, so it's true. Now, a less intuitive comparison, it's reference to an object. So this is defined with is or is not. And here's an example, right? So we have the same variables as before, A and B. And if we do A is B, we'll see that A is not B because they are pointing to different objects in memory. And this will spit out false. But if we do, as we saw previously, C equal A, now C is now pointing to the same object as A, so A is actually C. And there are some Boolean operations that you can do, and I mean, which its result is going to be true or false. So the operator and, if both conditions are true, then the condition itself is true. If one or the other is true, then the condition itself is true. Then we have another condition which is called not. And not, of course, if A is true, this condition comes out false. And if you want to do more complex Boolean operations, you can combine the previous one. So for example, if you want to have if A and B are true, or C and not D is true, then the output of this will be one single true or false depending on the values of A, B, C, and D. Okay, so we go to basic control flow statements. So if the first one that we're going to see is if, which is the one that I showed you in the very first example that we did, and basically it evaluates a condition, and then it executes the block that it's determined by indentation after the if. Then you should not forget that in the same line as at the end of the line where you're defining the condition, the if, then you have to add a colon. So for example, we have an example here. We have A equal 1, B equal 2. So if A is equal to 1, then you print A is equal to 1. Or then you can also add many conditions. So here I'm using elif, so it stands for else if. In C++, you do else if. Here it's just elif, one word. If A is equal to 2, then you print A is equal to 2. And else, which is the default condition, you do this. So what's going to come out of here, it's basically A is equal to 1 because the other two conditions, the first condition is being fulfilled. Then we go to a while loop. So a while loop, it's also a conditional statement, but this time it's going to be executing what it's inside of the indentation, like on the indentation level next to the while, until a certain condition is met. So this, for example, you define x equals 0, then your while condition is while x is less or equal to 5, then you print x, and then at each iteration you add 1 to the value of x. This is a special way to add 1, which is just putting plus equal 1. Instead of doing x equal x plus 1, you just do plus equal. And what this will print is basically 0, 1, 2, 3, 4, 5. Then at 5, it reaches it doesn't fulfill the condition anymore, so it comes out of the while loop. And we need to be careful because usually you can get stuck inside while loops if the condition that you set is never met. Something important to learn, it's these two statements, break and continue. So we can use break inside a while loop if to leave the loop that in which you're in. This also works for loops, which we will see after. So basically, it takes you out of the loop. And then we can use continue. What this does is that whatever is under the continue is not executed, and then it comes back to it goes to the next iteration. So in this example, we have x equal to 0. And then the same condition says as long as x is less or equal to 5, then we execute what's below here. So what we do here is x equal x plus 1 at every iteration. So this is as I showed you, there are many ways to define adding 1 to an integer. And then when we reach 4, we will get out of the while loop. So it will not actually print the number 5. And another condition is that if when the value reaches 2, it will not execute the rest of the code, and then it will go back to the next iteration. So it won't print 2 either. Okay. So this is the result. It only prints 1 and 3. Because actually we're adding, so it's not printing 0 either because we're adding 1 at the very beginning of the loop. Now the next control statement that we will see, it's for loop, and for loops are a bit special in Python. If you know any other, if you don't know Python, and if you come from other languages. So what a for loop is, it's that it iterates a finite number of times. And in the case of Python, for loops iterate over a sequence. So as we saw, there are different types of sequences: lists, tuples, dictionaries, or strings. For example, in this case, we define a for loop with the keyword for, then the variable that it's going to be iterated, which is character. Then we say we have to put in, which is defined in this sequence. In our case, we're using a string, and then we're printing the character. So it's gonna iterate over each element of the sequence, which in this case it's each character of the word robot. So what this is going to output is each of the characters in a different line. So it's gonna print R, then gonna print O, then gonna print B, and so on and so forth. Then if we do it for a list, then let's say we define this list, which has a character, the number 3, the string car in a double. Then if we iterate over each item of the list, then what's going to print is each item of the list. So A, 3, car, and 2.5. So if we want to do, let's say, a traditional for loop, so from a certain value to another value, we can use a range function. So depending on the arguments that you give to the range function, it gives you a list of ordered numbers. So for example, here, if you do range 5, it will create a list of 5 elements starting from 0. So because Python is a 0 index language. So for example, this is 0, 1, 2, 3, 4, 5. So it has 5 elements starting from 0. You can also define from which element to which other element you want to go. Remember, the second element in the range function, it's not touched. And then you can also specify the stride that you want to have between elements. So in this case, I'm starting from 5, and then on strides of -1. So it will go 5, 4, 3, 2, 1. This is the list that it's created. So for example, in this case, I'm saying I start from 4 to -4 in strides of 2. And of course, this is empty because I'm asking it to go positive. So the next value would be 6. So this will never reach -4. So this is why the output of this is an empty list. So what I wanted to do was actually go from 4 to -4 in strides of -2. And again, it doesn't get to the last value of the list. It goes 4 to 0, -2, and stop. And then we can write this traditional for loop, which is for I, which is generally the word that we use for iterations. Here, I don't know why it's marking me an error. But then we hope for I, and then in range of 5, which will give us the first example, and then this is going to print 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4 till 4. Okay, so now we go to function definitions. So a function definition, it's created by using the keyword def. And I will go through the elements of how to create a function. So we use, so def, it's this orange word that you see here on the left. And then you give, so here I'm creating just a basic example that does the same thing as the append list exclusive function. So you define the name of the function. Then you define the arguments of the function. So in this case, the argument is the list itself and the element that you want to append. Remember, for example, here, you don't need to specify the type as you do in C++. Then it's good practice to add a documentation string for functions. So here is the documentation string. And then you write the instructions, what you want to do with the arguments of the function. So for example, here to the list example, we use the built-in append function, and then we append the element that it's the second argument of the function. And then you can use the keyword return in case you want this function to give a value. So you can use this value to assign to a variable. And we can define functions in many ways. See?
Since the list is mutable, is it like we have to return the list example, or it does the change for itself?
It depends on the so here it depends on the scope that you're using, and we will see, because if this is defined inside of specific class, then it won't change outside of that class. So it will change inside of the class, but it won't change outside of the class. But if it's used, let's say in the same, I'll show you an example. If we go further and use, in that case that I will show you, list example, it's going to change because because this is giving you a specific name in memory. Okay.
Okay. Thank you.
Yeah. So we can define functions in many ways. So for example, if we don't have we can do it without arguments and no return values. So for example, here, this is just a function that prints the word hello. And let's see how we can call this function. So in this example, the value of append will change. Sorry, the value of list example changes, but because we are using it just to define, it will, so it will only change inside the scope. Sorry, I said it wrong, because actually, because you're defining a different name to the list that you're modifying. So here, for example, this is returning the list example, right? So the list is going to change. So list example is just changing inside the scope of this definition. But what's actually going to change is this list. So list is going to change, but because it's basically, you're just inputting the, so A is going to change, sorry, A is going to change because you're just inputting this A into here, and it's appending an element to this. So it's referring to the same object in memory. So if you print list here, then it's going to print 1, 2, 3, 4. And then if we use the function print hello that we just defined, which doesn't require any argument, then it will just print hello. Okay. So we can go to object-oriented programming, and now that we defined what a function is. So in object-oriented programming, everything is based on objects. And these objects are made of data and procedures. So every object belongs to a class, and each class has a specific data, which is called attributes. And this define the object, and each object has methods, or has procedures that are methods or functions. And these are operations that the object can perform. And an object belonging to a specific class, it's called an instance of a class. So for example, here we have the class student, and we'll see each of the elements of here, of this, that I'm showing you here. And this class basically defines what a student is in the context of our program. And I will explain each of this. But first of all, I would like to talk about the keyword self, which is very important in Python. So the keyword self is just to indicate that the method that we're defining in our specific class, which are the functions of that class, it's only for the instance that it's being created. And this is similar to the keyword this in C++, but in Python is much more used. So for example, in the example that I showed you before, we see self here in between these white squares. So self, what it basically means is that you're creating a class of called student, and then this self refers to the instance of this class. It's a hard concept to grasp, but it's basically because a function needs to know on which object it's acting. And when you're defining it, the object is not created. So what self does, it's telling you, okay, this is acting on the object that you're creating right now for this class. It's more or less like this. When you call the class, then you don't need to add self. In general, so now I'll go through the init. So in general, when you do object-oriented programming, there's a specific method that is called a constructor, which is basically what creates the object itself. This is what you use to create an object inside of your program. And in Python, the constructor is defined by this special method. So it's 2 underscores in it, 2 underscores and parentheses. So this is the method. I don't know why in Python built-in methods are in between on pairs of underscores, but that's how it is. The first argument, it's always self, because this means that you are creating an instance of the class itself. And here we have our constructor. So usually constructors are used to initialize values, and they can have arguments, they cannot have, they can be without arguments. So here, for example, what I'm using the constructor for is to specify the name of the student and its age. Just to not confuse, I use years, but it's and then the attribute itself, which is age. It's called age, so then it assigns years to the age. And this is used generally to also need to initialize and to create the object. And then I already mentioned a bit about attributes. So the attributes are created generally inside of the init of the constructor. And here, for example, our attributes are the full name and the age. Then we have the methods. So methods are created through function definitions inside of the class. So here we have 2 methods, which are getName, which will return the attribute full name, and getAge, which will return the attribute age. So here we see how to instantiate and call an object. So here on top, we have our class definition that I just showed you, and here below we have we are creating an object of the class student. So we're calling this object student1, and then we're giving the arguments that the class is asking. So the name, which is John Doe, and its age, which is 20 years old. And if we can assign the output of the getName function is the name of the student. So if we call the method getName, this will be assigned to a student1 name, and the same thing goes for age. If we call the method getAge for student1, we assign the value coming of the getAge method to student1 age. To call a method, you just call the object student1 dot getName parentheses. Whenever you're calling a method, you always have to finish with a parenthesis, and our program will just print out the student name and its age. Another way to specify this is a special way to print in Python. So basically, you define between curly brackets the 2 arguments that you want to print. So for example, here I'm printing first the student name, which is specified by the argument 0 of format, and then the age, which is specified by the argument 1 here of name student1 age. Okay, so now that we went through functions, now we talk about importing modules. So a module, it's basically just a Python source file that can expose classes, functions, and global variables. So it's basically a Python file that has classes or functions or global variables that you can use. Okay, so whenever somebody says a module, it's basically referring to a Python file. And we can import functions and classes from modules defined in a different file. And it's similar to the include function in C++. And there are three main ways to import a module, which I will go through them one by one. And some of these are more recommended than others, but it's good to know all of them just to know how they work. So first, this is the most basic one. So we import by just saying import and the name of the file. So everything inside of the file name.py gets imported, and to refer to a class or function inside of the file, we always need to prepend. So put it inside of the put before everything that it's inside of every function that we want to call or every class that we want to call from this file. We need to put file name dot. So for example, here we use import file name, and then to call a class inside of the file name, we do file underscore name dot class name, and then the method, and then the arguments. If you want to use a specific function, then you need to do file name dot function, and then the arguments of the function. Then the second way to import modules is use from the name of the file, import, and a star. So this imports again everything that is inside of file name, but here you can use directly everything that is inside of file name without having to prepend file name dot. But this is a bit dangerous, because if, let's say, you define a function in a separate file, and this can overwrite that function if it's called after. So you need to be careful. So for example, here you have from the name of the file, import the star, and then you don't need to prepend the file name here, but you can just use the class name directly and the method. But if you already had a class with the same class name, before this, it will overwrite that class, and then it will use this one. So you need to be careful with this. Then you can import, a specific class or a specific function from the file. So here, for example, you can specify the class name, and the same goes as in the previous example, that you can directly instantiate an object from or call directly a method from that class without having to prepend file name. And again, the same warning as before, it can overwrite. If you had a class named the same, it will overwrite on it. So here you can only import class name, and then this is a bit safer, because generally when we import a certain class, it's because we don't want to write it again in the new file. You can also specify the internal name that you're going to use for the module that you're importing. So for example, in this case, you import a file name as, and then it's just fn. So in this case, instead of prepending file name, we will just have to prepend fn. So here would be fn.classname.method, and the same goes for a function. So there are some already built-in modules in Python, which are sys, which are system-specific parameters and functions. This basically, for example, if you want to define a folder, you need to call functions and objects from this class, sorry, from this module. There's also OS, which is generally used for function, for operating system specific functions. So for example, if you want to call a specific screen on your PC, the command is different from Linux to Windows, for example. And then there's basic math functions. I think that we won't be using this too much because NumPy already includes a lot of most of the math functions. And there are many more included modules, and there's the documentation. So generally, this whenever you import, you put the modules that you want to import after the documentation string. So for example, so this is the documentation string goes on the top of the file, and then right below it you have the import of the modules. This is just makes things more readable and easier to share, and then it gives you more control over what modules are you using. So okay, so let's try what we've learned so far. So let's go quickly. Okay, student. Okay, so okay, so here we have our main. Give me 1 second. Okay, yeah. So this is a specific method. I added a note on the slide. Basically, whenever you run a Python file, it assigns specific variables. In the file that you're running, it's called it gets the name main. So for example, when I run this one, this variable underscore name underscore name underscore will get the name main. But don't worry too much about this now. So let's create a file which is going to be our student class. So let's call our file student. And now let's call our file a student class, just to follow what I put on the slide. Okay, so in class, we will have a definition of the student class. Let me just to be consistent, I'll go back in my slides. So we have our class student, then we put our documentation string, a class representing a student. Then we defined our constructor, which is defined by init. And then you see that PyCharm already autocompletes with self because you always need to add self. Then we have name, years, and then self dot full name equals name, self dot age equals years. Now we're going to define our specific methods, def get name. Again, it's choosing self. Then this returns self dot full name. You see that it's auto completing because we already defined the attribute in the constructor. Then we define our second method, get age, self, and return self dot age. Okay, so let's save this, and then in our main.py, let's now, so here, it doesn't have a documentation string for now, but let's keep it like this. So this is text that it's automatically created. This line is somewhat important because this top line, because it defines the encoding that you're using. But for now, it's not important for us. Here we're using UTF-8, but it's mostly for the strings that we're going to be using. But don't pay attention to this. So let's import from a student class, which is the file that we just created. You see that it auto-completed. We're going to import the student class, and then we're just going to use st, and then it's grayed out because we have not used it. Now it's marking me a squiggly line because when you define from the import, the first definition needs to have 2 spaces. It's standard. It's not an error. It's just let's say grammatical error. The code will run, but if somebody that is pretty strict sees your code, he might complain. So let's create our object here, student1, using our st, which is the name that we use to define our student class. Then we're going to call our student Jane Doe and specify her age to be 21 years old. And then we do a print, similar to what we did before. We have our curly brackets is 1 years old dot a format. Oh, and I'm forgetting something, of course. So, oh, well, no, let's do it like this. We do format student1 dot full name, which is the attribute. You see that because it's an object of that class, it auto-completes with the attribute. Then student1 dot age, and now we try to run this. Oop. I have an error somewhere. In my class itself. Because I'm forgetting the column. Okay. Now let's go here. And then we run it. And then here we see our print high function here. And then Jane Doe is 21 years old right here. And all nice and dandy. Okay. So let's go back to the slides. Okay. Okay, seems like we have half an hour to do the quick introduction to NumPy. So what is NumPy? NumPy is the core library for scientific computing in Python, and it basically boosted the development in Python in recent years, and it provides high performance multidimensional array object handling and tools. What I mean with this is that you can create matrices, tensors of many dimensions, and it's really powerful because it replaces a lot of time-consuming operations, like for example a for loop, with matrix multiplications. And if you already know how to use MATLAB, there's an introduction that it's NumPy for MATLAB users, and there's also a cheat sheet, which is basically a translation between MATLAB and NumPy. Okay. And then you can always check the documentation. This is always up to date, and it's very easy to understand. I think that with respect to other documentations, like for example, there's a linear algebra documentation in C++, that's called Eigen, that it's not difficult to understand, but that because of the nature of Python, NumPy it's easier to understand because it's closer to natural language. A fun fact is that NumPy has been out there since 2005, and the paper just came out last year. And everybody that does machine learning, everything has been using NumPy for years, but the paper just came out last year. Of course, now they're going to get tons of citations, but they lost 15 years of citations. So the basic element of NumPy are arrays. So a NumPy array is a grid of values of the same type indexed by a tuple. So basically, it's similar to a list or a tuple, but it's made of non-negative integers. And this can, as I mentioned, NumPy arrays can be multidimensional, and the number of dimensions of the array is called rank. The shape of the array it's given by a tuple, and it's giving the size along each dimension. So basically, you can have a 2x2 array, and this is going to be in a tuple. And you can initialize an NumPy array in several ways. So let's try this first example ourselves real quick. So since I am already a bit on time, I have already worked a bit this. So let me comment this out. If you want to do multiple lines comments, you can do control / and then this will comment a lot. So what I mean with slash is this symbol. And okay, so first of all, what's very important is that we need to import NumPy at the, before we use it, right? So I'm importing here NumPy as NP, and then the way we specify a NumPy array is by saying NumPy NP dot array, and then in between parentheses, then in between square brackets, we specify the values of the array. So we can also see the type of the array. So for example, here, the type that we're gonna get, it's integer values. And then there's a special method of NumPy arrays called shape that will give you the shape of the array. And then you can call an object from the array. Okay, so let me run this, which I'm gonna do with Control Shift F10. And then here you see the first line is printing the type. Sorry, here is printing, the type of A, which is NumPy array, and the array. Then it's a one-dimensional array because we're only specifying one, so the rank is 1. And this is done, we know this because we're only using one pair of square brackets. And the shape of the array is 3. And if we call the first element of the array, it will print out 1. Now let's modify this a bit. So if we add an extra set of square brackets, well, this will print. It's a shape. The shape will change because it's a two-dimensional array. So the shape determines the number of elements in each dimension. So for example, here the outer dimension only has one element, which is this array of 3 elements, and this is why it's 1 by 3. And then if we do A0, actually what's going to print, it's just the element itself, because it's just printing element 1 of that. But then if we do A0, 0, hopefully this is correct, it brings us back this one. Okay, so let's go back to our slides. And this shows a bit some other examples that you can try yourself. Okay. There are specific ways to initialize arrays. So if we want an array with only zeros, we can use a special initializer that's called zeros. And then you specify the dimension of the array. Again, remember that the shape of the array it's a tuple, so you need to specify between parentheses. So here we'll create the value that is printed here. And then we can also create an array with just ones. So again, the shape of this one, it's 1 by 2. Because it's two-dimensional, remember we're specifying 2 dimensions. The array will have 2 sets of square brackets. Then you can also use full, which basically creates an array of a certain dimension, of a certain shape, with a specific value. So here, for example, it's 7. It's an array full of 7s. Then a special one that is good for linear algebra is to create an identity matrix. So in MATLAB, we use I as well. So this will create an identity matrix of dimension 2 by 2. You only specify 2 because it's an identity matrix, and of course it's a square matrix. And then you can also create an array of random elements, as we see here. So similar to what we do with lists, you can index NumPy arrays, and then we can also use slicing. However, there is a bit of a difference with respect to slicing, because NumPy are multidimensional. So you need to specify the dimension over which you are slicing. So here we have an example, and I think I have this already written. Let's see. So okay. Yes, I have it right here. So, for example, in this case, so let's run it just to see what it prints. Let's make a bit larger this. So, for example, here, we're specifying an array, a 2-dimensional array, which is a 4 by 3, no, 3 by 4. No, 3 by 5. Let's just, I don't know why I'm suffering like this. Let's just find out. Dot shape. Yeah, 3 by 4. And we can slice it. So we specify a different array, which is so what it basically does is that from the third column, which is this one, sorry, from all the elements starting from the second column. So this is what we're specifying. Okay, so we're basically slicing our array to take the elements in the middle, right? So if our initial array is this one on top that I'm highlighting, we want to slice basically what's in these 2 columns. So to do that, we say that we want to take all the elements before the one that has index 3, and then we're going to do columns 1 to 3 before 3. And then what's happening is we're just basically taking the 2 middle columns of the array. So if we print A, we get this. If we print B, we do this. Something that is important to take into account is that because this is an immutable object, if we do this, if we assign, let's say, to the value 0, 0 of the array, which is basically these two, this is actually referencing to the same value in memory as A. So if we run this, we see that we're printing A, and we see that the value to which this one is referencing, which is B, changed to 77. So this is also to take into account whenever we are slicing and defining new arrays. Okay. So let's go back to our slides. Okay, and then there are different ways to slice. I would let you guys go through them. So we can use also something called integer indexing and slice indexing. So a slice indexing, if we use a slice, the resulting array will have the same dimension, the same rank, like let's say the same shape as the previous one. Whereas not the same shape, sorry, the same rank. And basically it will have the same number of dimensions. But if we only use a slicing, it will result in a reduction of the rank. So for example, in this case, for our A array, here on top, here we're using the slice indexing, right? So what will happen here, the output of this will have the same dimension. So let's try this in our code. Okay. So again, let's look at our A array. So this is our A array. So let's print. So first of all, we're gonna do a slice indexing, and then we're gonna do a integer, like the mix between the integer and slice indexing. And we will see that the shape, although it's referring to the same values, the shape is going to be different. Okay, so here we see that the dimension of the array changed. So here what we're calling is all the elements of the second row, right? If you only put the column, it will give you all the elements of row with index 1, which is the second row, it's this one. And then you see that the shape, it's only 4 because it's the number of dimensions minus 1. But in the case of this one, we have an array of the same shape, of the same rank as the previous one. So it has 2 dimensions, and this is 1 by 4. Okay. This is also important to take into account, because then if you want to refer a specific element of this and specific element of this, it's different, right? So for example, let's do this. So if we want to get a specific element of row A1, we would need to do 0, 0, whereas if we want to, here is marking me of array 1, sorry, this would be 0 only, and this would be 0, 0. Okay, so let's print this. Let's print this. Okay, and then this gives us the same result. Now let's try just doing this, which is basically we'll just get the whole value of the array that it's inside, and this is what happens. Okay, let's go back to our slides. Okay. This is very useful, which is Boolean array indexing. So it can this lets you pick arbitrary elements of an array using a Boolean condition. And it will only select the values that satisfy this condition. So for example, here, we have an array that is defined as 1, 2, 3, 4, 5, 6. And then what this will tell us, this condition, which is bool IDX, the condition here, it will put true in a matrix to the values that are larger than 2. So for example, here, only the values from the second row are larger than 2, and the top ones are less than 2. So the printout of this will be false, false, true, 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 true. So it's going to be another array made of Booleans, indicating the ones that satisfy the condition. And then you can use this Boolean array indexing to print the values that are true. So for example, a way to do this is by using the array that comes out of this bool underscore IDX, and this will print out these 3, 4, 5, 6, which are the values inside of the index. Just notice that it won't have the same shape. And then you can do the same, all of the same as we did before from this line, by just doing this, which is basically putting in between square brackets the condition. Okay. And there are plenty of data types that you can create using NumPy arrays. And in general, NumPy tries to guess the data type as Python in general. But you can also specify the data type yourself. So for example, here, you create the matrix, and then you can specify the data type inside. You can print the data type inside of the data type of the specific array that you're defining with this, which is a special method from NumPy array that's called dtype. And let's try this ourselves. Okay. Okay, so let's go here. Let's comment this. Okay. Let's go to our initial example. So again, we have our A matrix that is shown here. And this, notice that, so let's do something. If we print the dtype of A, let's comment this first. This is going to give us int 64. So it's an int of 64 bits, okay, of 64 bytes. Okay, and it is specified like this because all of the elements inside of the array are integers, okay? So what happens if I add an element to it that it's not an integer? So if we run this, what happens is that the element that you introduce to the array, it's not a double, as we expect, a floating point number, right? It's an integer because the type of the array, it's integer. So we see this again, and it's still in 64. So if we want to change the type of the array, we can specify it like this. So in this case, we want to float a float type number. Then we assign again our 42.5, and then if we print again, we'll have our 42.5, and then you see that it added a dot after each of the elements just to be sure that it's a floating type. Okay. Okay, so let's go back to the slides. Share. Okay. So this is an important part because we're using NumPy because basically because we can do math with it. And similar to MATLAB, you can perform mathematical operations with NumPy arrays. And they are both operators. So for example, just the plus sign, the star symbol, or you can also call them as functions. And here we have plenty examples. And for example, you can add. I won't do this. We're almost done. So I'm not going to try this in PyCharm because it's kind of self-explanatory and we're about to finish. But you can see here that to add two numbers, you can just use the operator x plus y, or you can use the function add. They do the same thing. This is just adding NumPy arrays. Of course, they need to be of the same shape. Then you can also use subtract. And then multiply the star. I will say it in the next slide, but just to stress it even more, this is coefficient-wise multiplication, so it's not matrix multiplication. Again, also divide is coefficient-wise division, and that goes the same for square root. So matrix multiplication. So the star operator again is not it's not matrix multiplication, it's element-wise multiplication. To do matrix multiplication, in Python 2, we're going to be using MP dot because the add operator is only defined at since Python 3. But they both have a bit of caveats. MP dot, it's not intuitive to say that the dot it's matrix multiplication. But add, for example, in Python 3, you cannot do multiplication by scalar, whereas when you use dot, if you put a scalar, it does the multiplication by scalar. So here's an example. You have two arrays, and here you do MP dot. So the MP dot, it does the inner product of W, or you can also do the multiplication between two matrices, which is B and W. Yeah, I think it's pretty self-explanatory what the matrix multiplication does. And there are some useful array functions that you can look at all of them in the documentation. For example, the first one that it's very common to use is sum. So sum, what it does, it sums all the elements in the array. So it will output, so for example, for this array, which is made of 1, 2, 3, 4, it will output 10. You can also specify the sum about a specific axis. So for example, you can specify the axis 0, and then it would print the sum of each of the axes. So for example, in the first one, it will output 4, and in the second one, it will output 6. And the other one, so for example, what it does, it sums 1 and 3, which is 4, and 2 plus 4. So it will output 4 and 6. And then also you can specify it about the other axis. And this will specify 1 plus 2 and 3 plus 4. And then you also have a matrix transpose, which is only by doing, you can do just by typing .t. So if you specify a vector, an array called defined by a matrix 2 by 2, if you do .t, then it will output the transpose of that specific matrix. And if you do the transpose of a rank 1 array, nothing happens because it's rank 1. It doesn't have 2 dimensions to transpose. And yeah, I think I already explained this at the beginning. Again, there are a lot of useful functions that you can check out in the documentation. There might be a lot of functions that we will have in our lab sessions that are not going to be clear, but if you look for that specific function in the documentation, you will find a definition and how it is used. In any case, also, don't hesitate to ask us any question. So are there any questions regarding this? Again, if you have questions, you can also send me and shoot me an email, or also send an email to Michele. If you still have problems with the virtual machine, I knew that some of your colleagues sent me emails to ask me if using the previous virtual machine was okay. It should be fine for the lectures that we're going to be doing. An advantage of the new one is that it loads faster, but one of your colleagues found a solution by just saving the state of the machine. So again, don't hesitate to ask. And then I think we'll see each other after Easter. I don't know if the professor has something to add.
Yes, so next Tuesday will be the next lecture, and it will start a chapter on kinematics of a rigid body. I think I will put the slides slightly earlier, such that you can print them and better follow, because there are some drawings that I might refer in some slides that are in previous slides. So it's kind of useful to have them printed. I will try also to use the surface, so I'll be going a bit slower, but I need to see the pace we go, because it might take, I might not write everything, let's say. Okay, for the rest, if you have any questions, just as Octavio said, send an email. Always download the latest version of stuff, because we are continuously updating stuff. Sometimes we find some errors in the slides and we correct them. And that's it. Have a nice Easter. Have a nice holiday as well. We close now the recording. I will merge this in with the previous one that I saw that was properly done in the end. Bye.